Hello and good afternoon, everybody. Welcome to SVC TechCon 2021. My name is Chinmay Trivedi. I am Process Technology Manager at Hauzer Techno. Today, I am going to talk about Cromatipic technology. We have Cromatipic technology, which is an environment-friendly technology for metallization on plastic with future-proof regulation. Just like all the presentation, I'm going to explain content of today's presentation about environment-friendly technology, which is inline technology for metallization on plastics, performance of Cromatipic technology, and technology which can achieve OEM requirements. To begin with, environment-friendly technology, as electroplating, which is conventional technology used in the market today, has a lot of waste, lot of chemicals which are generated, which is not healthy for environment. It has also limitation that it shows chipping. When you have plastic parts which are coated with electroplating, it has a possibility of chipping. There are limited base material which can be used with electroplating technology. And a lot of process steps, like 15 process steps used for electroplating. And each of these process steps has a difficult process window as well as possibility of scrap. Of course, the technology is not fully reach compliance. So with respect to these all limitation, we have alternative solution available, which is known as a Cromatipic. In parallel to these, there is a REACH regulation, especially in Europe, where we have observed that the European Commission has declared that hazardous chemical cannot be used for automotive industry. This is announced a couple of years ago. To comply this, the Cromatipic technology is fairly simple. As you can see in the picture, there are plastic-based material. On top of that, we apply UV lacquer, and on top, we apply PVD coating. These are two simple process steps. So the process is fairly simple and easy to use. It has a lot of advantages. To name few, as you can see, there are only two process steps, so only two layers available. It gives a lot of design freedom to the designing team, especially when you have a clipping area, which you would like to have a cover or masking. With this technology, those clipping area doesn't require masking in all the cases. The parts are much more flexible. As we know that plastics are flexible, when we apply Cromatipic on top of that, the parts are still remaining flexible. The technology is fully eco-friendly, so it doesn't use any kind of Chrome 6. The technology also complies REACH regulation. With this technology, we can use several plastics, ABS, ABS-PC, we can start with, and we have also development goals to achieve for PA, PP, and other plastic materials. So these are advantages which we go together with Cromatipic technology. As a second topic, we have the process, which is inline technology for metallization on plastic parts. To show you the detailed process steps, here is a factory schematic overview. This factory is available operational at Hauzer Iberica, which is located in Spain, Barcelona. To start with, we have a starting location where you can see the loading robot is there. The product is loaded at that location. This can be done with a robot or manual. Products will be loaded on fixture and fixture is loaded in the line. The product will immediately move to first process step, which is in the gray area. The complete gray area is clean room. This area has ISO standard clean room. So the air quality is continuously maintained so we can produce good quality products. As a first process step, it is CO2 process. So products are clean in this step. Then the product will move to the second step, which is lacquering process, where the lacquer is applied. The product will be sprayed with the lacquer, and then it will move to UV booth. As the schematic suggests, the UV booth is a little bit longer than other booth. So there are more UV lamps, there are flexibility available, and we can cure products very well. After that, product will move to the second robot, where the products will transfer from painting line to PVD line. This will be done automatic. So we do not need to have any manual hand runs. So we can reduce scrap rate, we can reduce mistakes. When the products are loaded in the PVD line, the product will pass through PVD chamber, which has 3 different processes. We will go into detail when we understand the PVD process. After that, products will come out and it will go towards the unloading station. After unloading, product will be visually 100% checked and packaged. At the same time, the remaining fixture will go for the fixture cleaning and it will be reused after the cleaning cycle. It is important to understand that this facility is available at Hauzer Iberica in Spain, where we are running job coating at this moment for several OEMs. We are also running development activities in parallel to improve the quality and have a validation with a lot of other OEMs. To start with, as a first process step, we have lacquer as a raw material. The lacquer has 2 different components. One is bright version or the possibility of matte version. As you can see on the left-hand side, the bright version has no particles, so the lacquer is clean and clear. So all the light will have a nice reflection. Whereas for the matte version, there are particles available in the paint. So the rays which arrives, which will be scattered and the refraction will be different. So you can see the satin effect. For this work, we have different matte version, as you can see different names, which can have different particles, different particle size. So the refraction will be different to meet different OEM standard as a visual aspect. We are using these different lacquers in the line. Before that, the products, when we put in the line, as a first process steps arrives at CO2 location. In CO2 chamber, the products will be clean. So products which has any dust, any surface particles, they will be cleaned with the help of CO2. So no particles will be available and product will be ready for the next process step for painting. The surface will become more sensitive to receive the paint. Then the product will move towards the painting booth, where the paint will be applied with the 6-axial robot. We have 3 different paint, which is fully automatic. So when we change from one paint to another paint, we do not need to stop the line. The robot will automatically change the paint. It will clean the necessary steps and perform required activity before it starts producing the parts. All the overspray which doesn't go on the product will be collected, and these can be treated or these can be used for the recycling process. Then the product will go through the UV booth, where we have 8 different UV lamps on top of it, and the product will pass underneath, and they will receive UV energy, so the products are well cured. All the lamps are located at different angles. There is a possibility that we can also do X and Y axial moving, but also height adjustments. Also, the lamps can be used at different powers individually, and the conveyor speed, which takes the products, can be also adjusted. After the curing, the product, when you look at it in the microscope, has a bright lacquer, has a clean surface, as you can see on the left-hand side, whereas matte lacquer can have particles, as you can see on the right-hand side. For the matte lacquer, if you use a different kind of matte, which has a different particle size or different composition, then you can see a different structure in the microscope. This is requirement depending on the customer or OEM's visual aspect. So we can meet visual requirement from customer. Once a product has a good quality, we also check the painting quality on the product. You can see on the left-hand side, the 3D geometrical difficult component, which has a different position where we measure thickness on one product. Also on one particular fixture, we have many products. As you can see on the x-axis, up to 16 products. And at different location, we measure thickness, and you can see the thickness uniformity over the height and over one particular product on circumference is much stable. What we can observe on right-hand side is the UV energy distribution when the parts are moving through the UV booth. The UV lamps are located at top in series, and they are running at different power, different angle, but you can see that the energy distribution is such a way that we can have the good cured product. We also check the quality of the product after curing, that we make sure that the parts are well cured. Once the part curing is finished, the part are moving to the Metallizer for the PVD process. In the PVD process, the first step is surface activation, which we carry out with the mid-frequency AC power supply. These are used together with the different gases. We typically use argon gas, which makes the ions, and these ions will change the surface tension and break the polymer change, which is due to the curing effect. This makes the surface completely hydrophilic. We can measure the contact angle and make sure that the activation process is well controlled. Then the products are passing through the middle chamber where the sputter cathodes are available. The sputter cathodes are having chromium as a target. So we are depositing continuously chromium metal, and the product receives the chromium, and they are chromium loop when they arrive in the last chamber. The last chamber has a PVDC process where we apply top coat as a PVDC layer, which can help to protect from the abrasion. Once we finish these processes, the products are out and we check several properties. So we are looking towards chromatipic performance from these. As a performance, the typical thickness ranges from 25 to 75 micrometer. Depending on product and the requirement from customer, we can control this paint thickness. Same goes for the chromium thickness. We can apply chromium thickness based on the desired property requirement. The color requirement is what we can achieve from the industrial standard. It has a metal cool touch because the product doesn't have any top coat or any paint available on the surface. So when you touch the product, you can have a cool touch effect, and we can produce matte or satin version together with the bright. To look into process of PVD, you can see that the products are moving through the line and it can have a different influence. So here we want to show on the left-hand side above L value graph and below B value graph, where within one frame, the uniformity is there and the product can have uniform color distribution. If we change the process parameters such as power or process pressure, then these color range can vary. And that can be seen with different processes with red, green, or purple color graphs. So when we change these parameters, the impact is clearly visible that the color values will differ. Apart from these, we can also measure the properties such as gloss, which arrives based on the different paint. So for the bright paint, you can see left-hand side, the gloss values. For middle and right-hand side, you can see that different paint is used, 236 and 237. Those are the numbers of our paint. And the gloss effects are different values for different contact, different angle for light. These are different values we can achieve for the requirement based on OEMs. When we apply PVDC layer, we can also achieve abrasion properties. To give example is a Volkswagen-based crockmeter, where the requirement is 2000 dry strokes. So with the help of PVDC layer, we can achieve these 2000 stroke dry requirement. Alongside these, we have done a lot of other properties for different OEMs. To give example here, Volkswagen, where the requirement is TL226 for interior. This is mainly for paintwork material. And you can see few of the requirement which we can pass from the specification. Apart from these, all of 226 requirement, Chromatipik technology is able to pass. Alongside these, we have also tested other requirements with TL528, where typically requirements are more harsh for exterior conditions or exterior component, such as cast test. As you can see, those tests are also mentioned here, and Chromatipik technology can achieve those requirements. We have also received some specific test condition like stone chipping test from Volkswagen, and we have tested Chromatipik coating with that condition. And we can see that Chromatipik is also able to survive that. Alongside these, at our facility in Barcelona, we are producing parts which are delivered for our customers and customers are using in the field. And one of the OEM is Renault. So we have several parts produced for them and we are delivering them, and the corresponding requirements we are able to achieve. The similar way, we have started a new project with PSA, where the product is delivered to them. And we have also tested those products for several of their requirements and we can achieve. For US customer, we have a General Motors where we are together with them testing several conditions, and some of them we are able to pass, which are mentioned here. So here I would like to show some of the products which we are using at our facility. Most of products we are doing as a sampling. Some of the product we are also producing on daily basis and delivering to customer, and customer is using in the field. So these are the example of those products. To summarize these, I would like to say that the Cromatipic is environment-friendly technology, which is definitely a preferred alternative with respect to electroplating, especially when we are comparing these process against chrome-free process. It is definitely a preferred solution. It can deliver bright and matte different versions, and it can meet several of modern industrial quality demands, especially related with PVD. With this, I would like to thank you everybody for your attention. If you have any questions, if you would like to get in touch with us, here is my contact detail. Thank you. Thank you very much. Have a nice day.